Hi there, my name is Kian Salazar, and we're here to tackle our final project slash the final problem on our machine learning uh, subject. Now, it is New Year, so I'd like to greet Happy New Year's to those that are watching this, and may you have a blessed New Year ahead. So let's get started. First and foremost, we're tackling the first problem, which is a simple problem, a wine quality, to which we will rate the wines if it's bad or good, or what makes a wine uh, high quality. We could predict that. We're going to predict that using our model of linear regression. So now we have now imported our packages here. We will use the sklearn model to train our model and data. Our min-max scalar scale data to maximum and minimum. The metrics SVC. SVC is actually scalable vector classifier. That means it scales the vector on a linear regression kind of model. And the classifier, and then the label encoder, and our logistic regression over here. So now we have to import our PD CSV file here. We will use the red wine quality. We will not be using the red and wine quality, only mainly red. So we have the factors: fixed acidity, volatile acidity, citric acid, sugar, chlorides, sulfur dioxide, total sulfur dioxide density, pH, alcohol quality, and sulfates. For this problem, we will be using the fixed acidity, volatile acidity, alcohol, and density right over here. So in our info, we will check if there is a null factor or null values on our data set, which is thankfully none. It is a simple data set after all. However, the quality is not a float, but it is an integer. So we will check the null values, double check, see it's all 0. And now we will use a histogram to visualize the number of the data. That's actually called EDA as EDA, yes. EDA or exploratory data analysis. Distribution of the data, yes. This is the histogram. We're using EDA to visualize the distribution of the data. Now our fixed acidity at 7.5 or 7.3, we have the 300 acidity, fixed acidity, but on 15.0, we had the very less. So at that acidity, measure of acidity, we have highest. Our volatile acidity, we have 0.7.5 probably, or 6.5 at the highest. Now we have our quality and our alcohol. Our highest is on clouds 300 over here, between 995 and 1000, 0.995 and 0.1, and our alcohol before 10 probably 6.5 and more than 300. So now we need to have the number data of each quality of wine, which is our 5 factors. So first and foremost, we will be tackling the fixed acidity and the volatile acidity. So now we have those diagrams. This would mean the quality is high if certain factors are either low or high. So the quality We have our fixed quality here ranging from 3 to 8, 3 being the least or bad quality and 8 being the highest quality. And we have the highest quality if the fixed acidity is before 14 and 12, so in between like 13. And our volatile acidity, the quality is high if the acidity is on between 0.8 and 1.0, so 9. And we have our alcohol. The quality is high if the alcohol is 14, also high, and the density is also, the quality is also high if the density is also high. Now we will separate this whether the wines are good or bad. So we determine that if our quality value counts, see this, there's so many quality here. So 5, it's all ranging from 3, 5, 6, 7, 3, 4, 5, 6, 7, 8. So on third quality, there's 10 wines. Our fourth quality is 53 wines, and the 5th quality 683 wines, and the 8th quality, meaning the high quality, has only 18 wines. So that's how many wines are in the high or low quality. So we're gonna separate that to bad and good. So the quality is now 0. Considered 0. We will not be separated it on 1 and 0 quality. 0 meaning bad, 1 meaning good quality. See that the 2 here is my mistake because I forgot to drop the best quality. So best quality is only 10. Good quality is 217, which is actually all. And then we have bad quality, which is 1,000 wines. Now we balance this all, dropping the best quality. Only we were focusing on the quality. Now in our table here, so there's 001. 1 is good quality here. Now if we count it again, it's now balanced, 217 and 217. You balance it by assigning the good quality and bad quality to respective 1 and 0. Sample fraction of 1 bad quality is the ratio of 217 of the good quality here. The bad quality should be the same as the good quality. Good quality, bad quality, and then we have our new table. Now we our new table ascending of whatever quality, which is the alcohol is the highest, except for the quality, of course, and the volatile acidity being the lowest. Ascending. Now we train our model. We're gonna train our model if it's precise. So we're gonna drop quality. Gonna train X test, and then we will min max scale it. The X train will transform, and the X test will also transform the X test. Models. Do we use the SVC or the scalable vector classifier for I in range of 3? Training accuracy, the metrics, validation accuracy, and the metrics score. So we have the training accuracy, it's 0.73 or 74, 0.74, that's 74%. Validation accuracy, that's 77%. Training accuracy, that is 85%. Or 86, 79, same as this, and then the same in the SPC. So this is our classification report. So accuracy in the macro average, 79%, weighted average is 79%, so very high. Now we will plot from good to bad to good quality. Now this is our factors that we have fixed density, volatile density, and alcohol. That after we balanced out the good and bad. So good quality, this is actually best quality, but we're focusing on the 1s and 0s. So fixed acidity quality is good if it's higher. Volatile acidity quality is good if it's lower. Density quality is great if it's higher or the same. And alcohol quality is great if it's high. So that's how you predict wine quality good to from bad to good, or good wines from bad, and the ratio of how many wines. Yeah, from the third to eight wines, the range of it. And now that's the end of our discussion. And so in conclusion, the five factors here um, is not always great to have all of it. It's not always high quality for factors to be that high. There should be some limit to it for it to be considered the best wine. So that being said, happy New Year's, everyone, and that will be the end of our discussion. Thank you very much for the time that you have, and goodbye.